Good morning, everyone. My name is Kapoor, and I'm an instructional faculty at University of Florida. My Spiffy peer instruction question is for students who are enrolled in data structures and algorithm courses. A few other prerequisites of my question, which is I'm assuming that students are taking the CS2 or DSA courses where the instructors are covering time complexity analysis. I'm also assuming that students are familiar with common orders of growth of different functions, such as quadratic functions grow faster than linear functions. Finally, I'm assuming that they have knowledge of analyzing the runtime of a function or program snippet using algorithmic analysis, and they can represent this runtime using big theta or big O notation along with tighter upper bounds. So without further ado, let's look at our question, which is what is the worst case runtime for the function foo in terms of big theta notation? Students will be given this snippet along with these 5 options, and then they can discuss this question, answer it, and select one option, which is we'll be using peer instruction. So I would encourage to pause the video for a minute and discuss it with your partner on what should be the probable answer. So why this is a great question is because we have, whenever we have a dual nested loop structure, students have this misconception that they multiply the time complexities blindly, because there are a lot of resources on the web that says that depending on the conditions of the loop, you strictly multiply the time complexities, which is incorrect. So this question kind of gives them a sense that in this case, it would not be quadratic, but something else, because you have to do some more work, especially in scenarios where the variable of the inner loop is getting manipulated by the outer loop. So what we discussed in the class was you can draw a table and try to predict what is going to happen for each iteration of the inner loop for different values or each step of the outer loop, which is in this case, let's say if you have a nested loop structure, we start from the innermost statement, which is in this case print bar, and that would be constant because it's a simple print statement. But the inner loop is running from 1 to m. Okay, so for the outer loop, when m is equal to some variable m, that would be the first value, and we are assuming that m is greater than 1, so we enter the outer loop. And for the first iteration of the outer loop, the inner loop is going to execute from 1 to m, incrementing by 1 at each step, which means it's growing linearly, so it would execute m times, which is this print statement is going to execute m times, okay, which is at a very broad level, we are trying to predict how many times the print bar is actually going to get executed for this entire function. Now we divide the value of m by 2. So m will be m over 2, and it will go back up to the condition of the outer loop, check if m over 2 is still greater than 1. Assuming it's still greater than 1, it will enter. The inner loop is going to now run from 1 to m over 2. Okay. So the print bar is going to execute m half times, because again, it's going to run from 1 to m over 2 and incrementing by 1 at each step. Next time, m over 2, m is the current, m's current value is m over 2. It will get divided by 2 at the next step. So the value of m will be m over 4. Assuming again m over 4 is greater than 1, this inner loop is going to execute m over 4 times, and so on. So this process is going to get repeated till m is greater than equal to 1, which is the last value of m would be 1. Okay. In that case, the inner loop will execute once, because next time it will be m over 2. So that should be 1 over 2, which is 0. And this series is kind of converging. So the overall runtime of this program is the sum of all of the steps for different iterations of the outer loop, which is the sum of this particular row. So let's say if we assume that we are representing it using Tm, that should be m plus m half plus m fourth up to 1. And this is a geometric series that adds up to 2m minus 1. So for the sake of the presentation, I'm not going to cover the proof, but here you can find the link on why this adds up to 2m minus 1. And thus this function foo runs in theta m time, which is the correct answer is C. Okay. Again, this is a good question because students have this misconception that they will get a quadratic or log linear time complexity, but the actual time complexity is linear. And if you have any questions, feel free to contact me. Thank you.